Courses in the cement industry. Present to you. In this course, you will see the most important, pneumatic conveying. Course 1. Pneumatic conveying is based on the physical principle that air, under certain conditions, is able to convey heavy materials. In nature, air can carry many substances, such as sand, cement, snow, leaves, and seeds. Pneumatic conveyor types are defined based on what kind of material is movable, and their source of airflow. The three main pneumatic conveyor types are dilute phase, dense phase, and semi-dense phase conveyors, where each can be pressure or vacuum driven. 1. Air slide. Air slide conveyor systems will quickly and efficiently convey materials such as raw and finished cement, fly ash, and precipitator dust. The simple combination of air pressure and gravity allows powdered materials to flow like a fluid. Air slide conveyors are very efficient and quiet, and with no moving parts, these conveyors are also extremely cost-effective and require very little maintenance. Air slide. Operation. 1. The flux slide is constructed as an inclined duct, with a rectangular cross-section, is separated by a diaphragm into an upper channel, and a lower channel. The diaphragm is fabricated from polyester, with the tightness providing the necessary degree of air permeability. 2. When the air is injected through the fan into the lower channel, the air will be forced up through the polyester, to the upper channel through the inlet branch, and accordingly the materials will float on this cushion, in the direction of fall of the flux slide. 3. The upper channel is provided with a perforated wear plate, which is installed to protect the polyester. We follow together. Operation. Switch on the fan for conveying, and aeration. Switch on the conveying equipments, for materials feeding. The presence of just one single hole will be enough to bring the entire airside capacity to half, and accordingly the lower channel will be blocked by materials. The flux slide can be used for conveyance of fine-grained materials having temp 80 degree and maximum 150 degree. The machine must be provided with warning signs to warn the operators of the danger involved in case of physical contact with the machine. Working pressure. Set the dedusting throttle valve to set the air pressure in the flux slide at the lowest pressure necessary to sustain the material's flow, which is around 200. Design features for air slide. 1. Ratio of compartment. 2/3 materials, and 1/3 air. Inclination. 6 to 12 degree. Volume of air. 1.5. Fan pressure. 250 millibar. 2. Degree of inclination depends on fineness of materials, and roughness porous partition. 3. The inlet section should be equipped with a protective wear plate. 4. The polyester fabric must be installed under proper stretching up to 2% lengthwise. 5. Modified the drive system assembly to have a bypass standby drive fan. 6. Dedusting system must run efficiently and run the airside under negative pressure for dust-free. 7. The polyester fabric must be perfectly bolted and sealed to the casing flanges. Preventive maintenance for air slide. 1. Periodically cleaning internally must be carried over, whenever shut down the air side to check the fabric, and also at the inlet section, and to observe any presence of holes, which will result to penetrate the material to air chamber and causing blockage to the air duct, every 2 weeks. 2. Regularly inspection to the dedusting system, to ensure the negative pressure to eliminate any risk of dust leakages. 3. Regularly inspection to the lower channel indicates any presence of dust, or materials in the channel, is a sure sign of polyester damaged, which required immediate replacement. 4. During replacement the polyester must be stretched approximate 2% lengthwise, hand test pressing to ensure the polyester is not moving up or downward direction. 5. Inspection covers should be always maintains airtight sealing. 6. Never utilizing a strong impact imposed on the side casing, to remove the blockage which accordingly, it will affect on the polyester fabric to move upward or downward direction and causing permanent obstruction, and reduce the equipment efficiency. 7. Monitoring the operating pressure, by means of adjusting the throttle valve, at the fan output 200 millibar, accordingly the fan suction filter, must be periodically checked and clean. 8. To ensure long operation to the drive fan assembly, it's important to keep the fan impeller in satisfactory balance, because running the fan with vibration, will reduce the lifetime of bearings and couplings. Case study for air slide. Frequently blockage of kill feed air slide. 1. Inspected the entire polyester fabric along the conveyor. 2. The air chamber is inspected, and found it's free of materials. 3. No change in the conveyor inclination angle. 4. The fan is working satisfactory, and no sign of wear was observed on the impeller. 5. Sealed all flanges and all inspection windows. We follow together, case study for air slide. The result of inspection was as follows. The dedusting system were observed not working satisfactory, which affected the fluidizing, and accordingly the inlet flow was higher than the discharge flow rate, which caused blockage. See this video.
We are going to inspect the kiln feeding air slide. We look at the close inside to see if there is any wear or cracks, especially the fixation at the joint. First, I clean the material on. Okay. Seems okay. Okay, one bolt is missing. I found the washer. Now we check the aeration box. If there is any material in, it's okay. That means there is no leaks inside. The fiber close is okay. Normally this operation should be done with the blower under operation to see if there is any holes on the polyester cloth. But unfortunately we cannot start for electrical problem, we cannot start the blowers. So today we just check like that.
2. Air lift. The AIRLIFT pneumatic elevating system conveys dry pulverized materials through a vertical pipe to discharge into receivers or bins at a substantially higher elevation. The AIRLIFT system is suitable for materials which can be fluidized by aeration without segregation. AIRLIFT systems are used for the cement, aluminum, copper, and chemical industries. Operation for AIRLIFT. 1. Put into operation the filters at the receiving station, and all conveying equipments downstream from the air lift, such as air slides for exhaust venting from the air lift. 2. Switch on the blower, for conveying and aeration. 3. Switch on the conveying equipments, for materials feeding. 4. The flow rate of material feeding to airlift chamber must be constantly filled to 3/4 of its height, which it represent its max capacity. The lower filling degree, the lower discharge capacity. We follow together operation for air left. 5. The distance, A, between the nozzle and wearing piece, is controlling the conveying air lift capacity. In case of power failure to the air lift blower, the following must be followed. 1. An electro-pneumatic relief valve, option, will be opened immediately. 2. Non-return valve below the nozzle, at the aeration base of the chamber, will be closed. 3. Fully open the hand-operated slide valve, to allow the conveying air to escape to the atmosphere, and then the same valve has to be gradually closed, when the air blower switch on again. See this video about air left. Design future for air left. See in this figure. 1. The internal discharge tube, with 1 meter long wearing piece, number 4. 2. A nozzle in the center of chamber base plate, number 5. 3. The distance between the nozzle and the wearing piece, A. 4. A electro-pneumatic relief valve, number 16. 5. Non-return valve below the nozzle, number 10. 6. Hand-operated slide valve, number 17. 7. Manual valve for adjusting the flow rate of aeration air, to fluidize the materials, number 8. We follow together, design future for air left. See in this figure. 8. 2 pressure gauges to indicate the pressure ahead of nozzle, number 11, and discharge pressure, number 12. 9. 96% of the total compressed air goes to the nozzle, and 4% is distributed to the aeration floor. 10. The relation between the materials column in the vessel, and the air material mix in the conveying duct. We follow together, design future for air left. In this figure shows the height of the vessel raises, as the conveying height is increased. In this figure shows the relation between the diameter of the vessel, and the diameter of the conveying duct, depending on the conveying capacity ton per hours. The air consumption, 0.8 to 1. Maintenance schedule for air left. 1. Monthly check up the aeration cloth, for any possible damages or wear. 2. Monthly check up the non-return valve below the nozzle, for possible stuck up or wear which might causing malfunctioning. 3. Periodically check up the wall thickness of wearing piece. 4. Periodically check up the wall thickness of airlift discharge elbow for possible wear. We follow together, maintenance schedule for air left. 5. Periodically check up the pressure gauges, for possible malfunctioning. 6. Visual inspection to the air chamber, for possible wall cracks or materials existing. 7. Check up the relief valve and manual slide valve, and manual aeration valve for possible internal damages. 3. Pneumatic conveying pumps. The principle of pneumatic conveying pumps is based on the fact that bulk goods can be moved by means of air through pipelines. The flowing conveying air transmits a propulsion force on the bulk material and thus conveys it through the conveying line. Main pneumatic screw conveyor. 1. Peter pump. 2. Fuller pump. Important information. 1. In general, the pneumatic screw conveyor's arrangement consisting of feed pin, pump screw, conveying pipelines. 2. The material's compression is one of the highest sources of energy consumption, as well as of wear of the conveyor's screw. 3. The compacted material forms a material seal, which prevent the reverse flow of air from the mixing chamber to pump is too low. 4. Improper sealing will affect the pump performance and increase the conveyor screw wear. 5. Pressure drop through conveying pipeline, which depend on numbers of elbows, and horizontal or vertical pipeline. 6. Pipe diameter depends on the pump size. 7. The range of material conveying speed is about 18 to 25 meter per second. 8. Energy consumption equals energy consumption of pump plus energy consumption of blower. Example for pneumatic pumps. Peter pump type, X300. Design features. 1. The pump is a pressure screw feeder, serves for feeding of cement from atmospheric pressure areas to the conveying gas flow of a pneumatic conveyor line, which is in overpressure condition. The pumps functions as sealing element and prevent gas blowbacks into the inlet area. 2. The pump screw works as a feeder and as a sealing within the pump. The screw design and speed depends on pump capacity. 3. For perfect function of pump, even material feeding and permanent venting of inlet area by connection to a suction filter. 4. The power consumption at the screw depends on throughput capacity, speed, conveying material characteristic, amount of back pressure in the conveyor pipe, and the screw pitch. The maximum material temperature is 200 degrees. Main element for Peter pump. The pump is consisting from 5 main groups. 1. Movable bearing and shaft seal. 2. Material inlet. 3. Screw housing conveyor screw. 4. Material outlet. 5. Fixed bearing and shaft seal. Main element for Peter pump. The pump is consisting from 5 main groups. 1. Movable bearing and shaft seal. 2. Material inlet. 3. Screw housing conveyor screw. 4. Material outlet. 5. Fixed bearing and shaft seal. Main element for Peter pump. The pump is consisting from 5 main groups. 1. Movable bearing and shaft seal. 2. Material inlet. 3. Screw housing conveyor screw. 4. Material outlet. 5. Fixed bearing and shaft seal. 1. Screw shaft support. Movable bearing. Fixed bearing. Two. Shaft seal. Inlet area. Outlet area. Shaft seal. Modified the outlet shaft seal. Due to high consumption of seal rings, and changed to stuffing box type. Advantages for pneumatic conveyors. 1. Small space requirements and dust-free operation. 2. Pipelines can be easily installed into existing plants, since these conveying lines allow the bypassing of possible construction obstacles. 3. Pneumatic conveying pipes require no lubrication, and there are not complicated and expensive parts as drive chains, belts, speed reducers to repair or to replace. 4. Costly labor charges, and the necessity of stocking spare parts are greatly reduced. Disadvantages for pneumatic conveyors. 1. Wear occurs in pipelines, especially in elbows, when conveying cement. 2. The air used to convey must be cleaned in dust collectors before discharge to the atmosphere, thus resulting in an increase of the equipment investment. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.